Welcome everyone to today's video where we're diving deep into the fascinating world of chemical compounds. I'm thrilled to explore a compound called acetal with you, and we'll spend the next 5 minutes or more unpacking its structure, properties, uses, and some critical safety considerations. As a content creator passionate about science, I love breaking down complex topics like this to make them accessible and exciting. So grab your lab notes and let's get started. First, let's take a look at what acetal is all about, starting with its chemical structure. Acetal has the molecular formula CH3CHOC5, which might look intimidating at first, but it's actually pretty straightforward once we break it down. Picture this. There's a central carbon atom at the heart of the molecule. Attached to it, we have a methyl group, CH3 on one side, a hydrogen atom, H on another, and two ethoxy groups, OC2H5, where each ethoxy group is an oxygen atom bonded to an ethyl group, C2H5. This setup makes acetal a diethyl acetal, specifically derived from acetaldehyde and ethanol reacting together. The two ethoxy groups give it a symmetrical vibe, which plays a big role in how it behaves chemically. Imagine it like a tiny molecular shield. Those ethoxy groups are key to its function, and we'll see why later when we talk about its uses. For now, just know that this structure is what defines acetal, also known as 1,1-diethoxyethane, and it's got a Cas registry num. Now, let's get into some of acetal's properties. These are the details that tell us how it behaves in the real world. Here's what we've got. Molecular weight, 118.17 grams per mole. That's a measure of its mass, giving us a sense of its size. Boiling point, 102.7 degrees Celsius. This is pretty moderate, meaning you can distill it without needing extreme heat. Super handy in a lab. Density, 0.8314 grams per centimeter cubed at 20 degrees. Since water's density is 1 grams per centimeter cubed, acetal is lighter and would float on water if you mixed them. These properties make acetal easy to work with in practical settings. That boiling point suggests it's stable enough for processes like distillation, and its lower density is a fun fact to visualize. Think of it bobbing on top of water like oil. These numbers aren't just stats. They're clues to how acetal fits into experiments or industrial processes, which we'll explore soon. Speaking of practical use, let's talk about how acetal shows up in the real world. Specifically, how you might buy it. The info I've got lists it in different sizes. 250 milliliters for $170 USD, depending on exchange rates. 1 liter for around $410 USD, and a tiny 5 milliliters for roughly $70 USD. These prices and volumes tell us acetal is valuable, whether you're running a small experiment or scaling up for something bigger. Plus, there are product codes like 1022-1ATFS, 1022-2500 for the 250 milliliter size. Details that matter if you're ordering it for a lab. As a content creator, I find this fascinating because it shows how science meets commerce, bridging the gap between theory and application. Before we get too excited, let's talk safety, because no chemistry video is complete without it. Acetal comes with some hazard warnings. A flame icon means it's flammable. Keep it away from sparks or open flames. No lab fires on our watch. An exclamation mark signals potential health risks, like irritation to skin or eyes. So gear up with gloves, goggles, and maybe a lab coat. There's also the meaning danger, driving the point home. Handling acetal safely means treating it with respect. Always check the Safety Data Sheet, SDS, for the full scoop on storage, handling, and what to do if something goes wrong. Safety isn't just a rule, it's what keeps the fun in science. So, why do chemists care about acetal? Its uses are where it really shines. Acetal is a star in organic synthesis as a protecting group. Here's how it works. Imagine you're building a complex molecule, and there's an aldehyde group you don't want reacting yet. You add acetal under acidic conditions, and it wraps that aldehyde in a stable acetal shell, masking it. Finish your reaction, then use water and acid to peel the shell off, revealing the aldehyde again. This trick is huge in making drugs or fine chemicals. It's like putting a do not disturb sign on part of your molecule. Beyond that, acetal doubles as a solvent or an intermediate in creating flavors and fragrances. That fruity scent in your favorite perfume, acetal might have helped make it happen. Its moderate boiling point and density make it a dream for these processes, too. For a quick history lesson, acetals like this go back to the 19th century when chemists figured out how to protect carbonyls. Acetal itself comes from reacting acetaldehyde with ethanol, a classic move that's been polished for today's industrial scales. Want to try something cool? In a safe, controlled setting, like a lab with a fume hood, you could show acetal's reversal. Mix it with water and acid to break it back into acetaldehyde and ethanol. Watch for color shifts or that distinct acetaldehyde smell carefully. It's a simple demo that brings the chemistry to life for your audience. To wrap up, acetal is a bridge between theory and practice. Its structure, properties, and uses make it a gem in chemistry. From protecting groups to flavy production, it's got a story worth telling. I hope this deep dive sparked your curiosity. Drop your thoughts or questions in the comments. What compound should we explore next? If you love this, hit like, subscribe, and let's keep the science vibes going. Thanks for watching, and stay curious. See you in the next video.